A farmer has 800 meters of fencing to create 4 identical rectangular enclosures as shown in the diagram. We want to build a model as a function of x only that represents the total area the farmer can enclose. So here's the diagram of the structure the farmer wants to create with his 800 meters of fencing. We want a model that is a function of x only that represents the total area the farmer can enclose. So let's think about the total area of all of these enclosures here. So the area, since this forms a rectangle, is going to be the base times the height. Well, the total base here, since these are all identical, each of these is of length x. So the total base here is a total of 4x, and the height is y. So right now the area of the enclosure is 4x times y. Well, we wanted a model that's a function of x only, meaning that we want to eliminate the y variable. And that's where we're going to need a secondary equation, sometimes called a constraint equation. So this right here we would call the primary equation that we're being asked for, and then we're going to need a secondary or a constraint equation that will allow us to rewrite y as a function of x. The piece of information we haven't used yet is about the 800 meters of fencing that the farmer has to create these structures. So that is the constraint. That is what the farmer is limited by, the amount of fencing he has. So he has a total of 800 meters to create all of these boundaries here, right? All of this fencing. So let's think about the horizontal pieces. So I have 4 copies of x along the bottom and also 4 copies of x along the top. So he has 800 meters of fencing to create a total horizontal fencing of 8x, plus he needs to create all the vertical fencing pieces for each of the 4 rectangular enclosures, and each of these is a height of y. So we have a total of 5y. So that's going to be added on to the horizontal pieces, so 8x plus 5y. All of that has to be created using 800 meters. So here is my secondary or constraint equation, and I'm going to solve it for y. So I'm going to try to get this y by itself. I'm going to subtract the 8x, so I have 800 minus 8x is equal to 5y. And then I'm going to go ahead and divide everything by 5. So now 800 divided by 5 is 160 minus 8/5 x is equal to y. So now I can go ahead and substitute that in to the primary equation. So this whole thing is going to get substituted into this y. So that I have area is 4x times 160 minus 8/5 x. So this is now a function of just x. It was originally a function of x and y. Now it's just a function of x, or a of x is equal to, if I choose to go ahead and distribute this in, I'm going to go ahead and have 640 x minus 32 over 5 x squared. So this right here is my answer. It's a model that represents the total area as a function of just